This is the problem 2 of our assignment on voltage dividers. So we have our circuit here, we have a battery V, and we just go through the three series resistors R1, R2, R3, and we want to find out what the voltage at this point is on the circuit, VA, and this point, VB. And the standard way to do this is to find the effective resistance, which is R1 plus R2 plus R3, and divide that into the voltage to get the current. So we have the current here in terms of the known quantities, and then we apply Kirchhoff's voltage law. Now the way we normally do it is we go around in a full loop, and we'll say V, we go up in voltage V, and then we drop I1, or I times R1, I times R2, I times R3 must equal 0 as we go around the circuit. But we can also use it here, and we can say that we go up in voltage V, and then we drop down by an amount I times R1 to get to the point here, and that is VA. So that is the voltage. So VA is equal to V minus I times R1. It's the same as the source voltage here, minus the dissipation of energy and voltage going through resistor R1. Similarly, for point here, which is V sub B, we go up in voltage V, and then we drop I R1 to get to here, and then we drop further I times R2 to get to this point, and that is equal to V sub B. So we can use these two equations here to solve for VA and VB. And if we do that, if we take this one here and we just do some algebra to come down here, we'll find that VA is equal to the R1 plus R2, or R2 plus R3 divided by the sum, and then V sub B, again, if we take this equation here and we go through the algebra, we'll get this expression that V sub B is equal to R3 times that sum. So what you can see is that the voltage at a place in the circuit is equal to the amount of resistance up from ground divided by the sum of the resistances. For example, here for V sub A, this is at ground, 0 volts, and then we go up to here, and the amount of the resistance below that point, so to speak, is R1 plus R2 plus R3, and that goes in the numerator here. So these are standard voltage divider equations. And then for V sub B, similarly, we go up here and we just have R3 separating this point from ground, so it's the one that goes here. So that's the methodology in order to find V sub A and V sub B.